Hi everybody, welcome back. We are going to finish up on circles today. You'll have a quiz coming up, so we'll do a review and then you should be good with circles and we're going to move on after that. All right, so this has to do with area of circles again. Remember the area for a circle is pi times your radius squared, okay? So you always have to know that pi times your radius squared is the area for a circle. Diameter times pi is your circumference, okay? So on this one, it's kind of the same picture we had in the last lesson. It says the area of the field is about 500,000 meters squared. That's the square area. What is the field's exact area to the nearest square meter, okay? So it says assume the side lengths of the square exactly 800. So it's telling me that every side is 800. So if I think about this and went all the way across, that would be 400 because the whole square is 800, which means the diameter is 800. If I thought about from this point to this point, that means the radius has to be 400, okay? So that's how I would start this problem. And then to figure it out, I'm just going to follow the area formula, pi times my radius squared. So I would do area is equal to, we're going to use 3.14 for pi, times my radius was 400 squared, okay? Now I can just kind of rewrite this 3.14 because I can figure out what 400 squared is, because I would do 4 times 4 is 16, and this would be 1, 2, 3, 4 zeros. Or you could do it on a calculator. It doesn't matter, okay? It truly doesn't matter. So I just did 400 times 400. Then I'm going to use a calculator because I'm not multiplying that bugger out, okay? So I'm using my iPad calculator for today. So I would take my, what I think it was, 660,000. So let's put that up there. There we go. 0, 0, 0 times 3.14. And I'm going to get 502,400. Okay. So the choices I have here are 502,400, which is exactly what it is. This would be meters squared. Okay. And then it gave me some other choices where I too have made a mistake somewhere. Okay. So that would be how I would do that problem. Figure out the radius first and then go on to it. All right, on the second ones, these are a little tricky, but they're really easier than they look. Okay, so we're going to go through this. It says each square has a side length of 12 units. I'll just say units. Compare the areas of the shaded regions in the three figures. Which figure has the largest shaded region? All right, so here's how I'm going to have to figure this out. I know that all the way across is 12 units. That means that my radius is half of that. Okay, so to find the circle, so I'm going to have to find the shaded region and I'm going to have to find the circle region. All right, so the whole square. So what I'm going to do is I'm going to find the area of the whole square and then I'm going to subtract out the circle in the middle. So this would be the whole square would be 12 times 12, which is 144. That's going to be true for every one of these, okay? They're all 12 units, so the square in all of them is going to equal 144. The whole thing, including the circle in the middle. All right, so my job now is to figure out the little individual circles. So the first one shouldn't be too bad. I know what the radius is. It would be, so my circle would be pi times my radius squared. Okay. On this one, my circles would be 4 because I have 4 of them. And I'm going to have to multiply it by my radius squared. And on this one, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Times pi times my radius squared. But we're going to figure out the radiuses in a minute. Okay, we're going to go do number 1 first. So I'm just going to figure that out. I would do 36. Oops, I'm going to clear that first. 36, 6 squared, so I got to do that first, times 3.14. and I get 113.04 units squared. Okay? So what it's not asking me about the circle. This is what my circle was equal to. Now I'm going to have to subtract them. Okay? So I'm going to take the area of the entire square, which was 144. I'm going to subtract the area of the inside circle, which was 113.04. And I don't know what that is. So I'm going to do 144 minus 113.04. And I get 30.96 units squared. Okay, so I did the square, take away the circle, equals that. All right, so I know my squares were the same in all of them. So what I need to figure out here is my radius. Okay, again, all the way across was 12. So from here to here would be 6. Does that make sense? Because if the whole thing across is 12, that means this diameter is 6. These are all the same circle. So that means that from here to here would have to be 3. So when I do this, I have 4 circles times pi times my radius, which is 3. It's only half of a circle, squared. Okay? When I multiply that out, I'm going to do my 3 squared first, which is 9. So this would be 4 times, I'm going to do 4 times 9 times 3.14, because it's all multiplication, it doesn't matter. So I'm going to do 36 times 3.14, and that should sound familiar. 36 times 3.14. I get 113.04 units squared. So guess what? When I subtract my square minus all my circles, I'm going to get the same thing. Square take away circle is going to give me the same thing because my circles were the exact same as that big circle, just in a little bit of a different formation. So everything left over is what I'm going to have. Okay? So this was the area we're actually finding, the shaded part. All right, so those two are identical. Let's see if we're 3 for 3. So this one, what I got to figure out is my radius. Again, so it's 9 times 3.14 times my radius squared. All right, so again, all the way across is 12. Okay, this is, I'm going to take 12 divided by 3. So this diameter would be 4, this diameter would be 4, this diameter would be 4. So if my diameter is 4, that means my radius is 2. Okay, so all I did is I said, this whole thing is 12. I had 3 circles, so each one of these is 4 across, but I need the radius, which is half of a circle. So I would multiply it by 2 squared, okay? Now again, when I multiply this out, I'm going to do 9 times 3.14 times 4. Guess what I'm going to get? 113.04. When I subtract that again, because these were all the same. So when I do the 144 minus 113.04, I'm going to end up with the same thing, okay? So even though it doesn't look like it, looks like that area would be less. These areas that are shaded in, the ones outside of the circle, are all exactly the same. And I would have to figure that out to be able to do that, okay? So it's just kind of applying what you know with the circle. All right, so you're doing kind of the same thing here. We're just going to kind of figure out how to do this, and it's breaking apart a problem and putting it back together, okay? It says each square in figure D and E have the same side lengths of 1. So I'm going to say there's one here, okay? The squares in here, here's one square, here's one square, here's a square, and here's a square, okay? So I had one square here, and I have one square here, okay? So it's saying each one has a unit of 1, so a square is base times height. So this would be 1 times 1, but I have 2. So 1 times 1 is 1, so this is 1, and this is 1. So my squares together are 2 units. What did it say, units? Yep. Okay, if I do the same thing here, I'm going to do the squares first. I have, each square is 1 times 1, so each square is 1 unit. That's 2 squares, 3 squares, 4 squares. So my squares are 4 units. 4 squares at 1 unit apiece, okay? All right, now my circles. Even though it doesn't look like it, you could be able to figure that out. I know that this square is 1 all the way around, okay? So my radius is 1. How many circles can I make? I have a half a circle and a half a circle. That makes 1 circle. I have another half of a circle and another half of a circle that are identical. That makes 2 circles, because if this is 1, then that's 1. Then that's 1, then that's 1, then that's 1. So I have 4 circles, all with a radius of 1. Okay, so if I want to figure that out, I would do 4 times, because I have 4 circles. I have 2 circles. I have 4 half circles. Sorry, I know what I mean. I have 2 circles, 4 half circles. I have 2 circles times pi times my radius squared. Okay. So my radius squared is 1 times 1 is 1. So I'm going to do 2 times 3.14 times 1, which is going to be 6.28. So my circles are going to be 6.28. Now what I want is the whole thing. I want my squares plus my circles. So if I did my squares plus my circles, we said the squares were 2 units. The circles are 6.28 units. Together they are 8.28 units squared. Okay, so for this one, it's 8.28 units. On the other one, okay, I'm going to kind of do the same thing. I still have a radius of 1 because it's halfway through a circle, okay? But what I have is a whole bunch of quarter circles. So here's 1 quarter, here's 2 quarters, 3 quarters, 4 quarters. That's 1 whole circle, okay? 1, 2, 3, 4 quarters. Then I have 1 quarter and 1 quarter. Or I could say I have 1, 2, 3, 4, 5, 6 quarter circles, which is 6 over 4, which is 3 over 2, or 1.5 circles. So this one has 1.5 circles. Okay? So when I go to figure this out now, I know my radius is still the same. I have 1.5 times pi times, my radius is still 1. It's still halfway through the circle would be 1. Okay, so instead of 2 times 3.14, I'm going to do 1.5 or 1.5. That didn't work. 1.5 times 3.14, and I got 4.71. Okay, squared. Now, that's part of it. I still have to add on my squares, right? Looks like I'm done, but I'm not. So these were my circles. So if I do my circles plus my squares, so circles plus squares would give me, my squares were 4. My circles were 4.71. I get 8.71 units squared. So this guy had more area. Okay. Now, the second question on here is just going to ask you about the perimeter, and it's kind of the last one we're going to do. We're not going to do the 9.3 on here. But I do want to show you how you do the perimeter, because it sounds like it's a lot harder than it is. Okay. So I'm going to look at how many circles I have again. So on this one, I'm going to do the circles first, and then I'm going to look at the squares. So perimeter means all the way around the outside. Okay, and we're assuming you go all the way down. So again, we had 2 circles. So the figure D has 2 circles with a radius of 1. Okay. This one I know had E has 1.5 circles at a radius of 1. So I'm going to use the information I already know, okay? Now, what I need to figure out is the square part, okay? Now, I'm doing perimeter. I'm just going to count. This would be 1, 2, 3, 4, 5, 6. So my square is going to, oops, forgot the E, is going to equal 6 units, okay? I just counted it. On this one, I'm going to count my square again. 1, 2. I'm not going all the way around because those are on the inside. I want the perimeter. 3, 4. So my square is going to be 4 units. Okay, so all I really have to figure out is the circumference of 2 circles and the circumference of 1.5 circles. Remember, circumference is diameter times pi. So I'm just going to add this on all at one time. So this is my 6 squares plus, if my radius is 1, that means my diameter is 2 times pi. But I had 2 circles, so I'm going to multiply it by 2 circles. So my squares times the circumference of the 2 circles, okay? Or circumference of one of the circles, I should say, times it by 2. So when I multiply that, remember order of operations, so I'm going to do 6.28 times 2 and then add on 6. So 6.28, just did that, times 2, and then I'm going to add 6. This gives me 18.56 units, okay? So I found the area of the square, and then I found the circumference. All right, so this one, remember, we had 1.5 circles. And we had, the squares were 4. I'll do that one in green. Oops, I gotta move this up for you guys, sorry. All right, so when I go through this was my squares, 4 units, plus my radius was 1, which means I need diameter times pi. So my diameter is 2 times 3.14. How many circles did I have? I had 1.5 circles, okay? So my square, just counted up the sides, the area of one of the circles, but I have 1.5 of them. So when I multiply that out, again, I've got to do order of operations and add on the 4 last. So I would do 6.28. So 6.28, that's this part, times 1.5 plus 4, I get 13.42 units. Okay, so the circumference, the other one is actually bigger. So D is actually bigger in the circumference, okay? So it looks like a lot of work. You just have to organize it in a way that, okay, I found this, I'm gonna add them together, okay? I did it in different colors, so hopefully that would help. So it's just taking what you know about circles and applying it to different shapes that have circles in them, okay? This problem is really hard. I actually did this problem, and it's just so the numbers are really hard, so we're not even gonna go through it, but I'm gonna explain what I would do. All right, so if I wanted to find, what it's asking me is how much area is just the running track, okay? So not the inside. So what I'd have to do is I have to find the area of this whole thing, which would be a circle and a rectangle, and then I'd have to subtract out this part, okay? So I'd find the area of the whole thing, which would be 1 circle and 1 rectangle. I'd find the area of the middle part, which would be the little circles, 1 circle and a little rectangle, then I'd have to subtract them out. It's just the numbers were huge, and I'm sure it has to do with the regular track, but the numbers were too big to have to worry about right now when we're learning circles. All right, so here's your summary page. This should help you, okay? So it's just saying the relationship, you got to know the area and you have to know the circumference, which means you need to know a diameter and a radius, right? You also need to know, like if it's asking for a square or a rectangle or a triangle, how to find those, because sometimes it's going to ask you to find something like, let's say, look like this, okay? Where you'd have a half a circle and a triangle. So if I did this, I would find the half a circle plus the triangle area, okay? So it's just kind of taking things apart and putting them back together, okay? This part's just showing you that, okay, let's say I wanted to find a third of this, or you only wanted to look for this shaded part. I'm gonna find the area of the whole thing, and I'm gonna multiply it by 1/3, or divide it, I'm sorry, in the wrong part, or divide it by 3. So if I just want this, I'm gonna find the whole thing, and you could divide it by 3 or multiply it by 1/3. That's the same thing because I'm taking 1/3 of it. So it's just a way to figure out how to work with different circles using what you know. All right, you guys have a fantastic day. It's raining today, so I hope the weather is a little bit better when you're watching this. Talk to you later. Bye.